starting today is because it's 3rd Jan and today is my birthday. So yeah, that's the reason I thought why not start this today at this auspicious day. Cool. So we will see everything from the very brute force to actually recursive approach, which will actually be good, and you will see everything intuition based, and then we'll go on to the bottom up approach also. Then we'll go on to 2 pointers, and in the end we'll also have a look at this thing. You will see what is this and how it is required. And again, it has been asked by quite a lot of companies recently, so if you have your interviews lined up, be prepared, it will be asked. Now the question just says that we are given a string S, and that string S we have to return the longest palindromic substring. Now substring is any part of the string which is continuous. Palindromic is something which reads same forward and backward. So a part of string which reads same forward and backward will be a palindromic substring, and such palindromic substring I have to find which is longest possible. So in this you obviously will see that BAB, because it is a substring, it is continuous part of the string, it is a substring, it is palindrome because it is reading same forward and backward, it is reading same. Or to just find out if something is palindrome or not, you can just compare the end portions. For example, MAAM, right? This is a palindrome. This you can see it is reading same. For example, RACECAR, RRAACC and E in the middle. So this is also a palindrome. So you can just compare start and end, and thus you can figure out if something is a palindrome or not. And the same way you can see two same characters, it will also be pairing up, and that is also a palindrome. So I have to just figure out the longest palindromic substring in this entire string. Now the first very brute force way which comes in our mind is that, okay, bhaiya, you said that you want to find substrings, longest palindromic substring. So let's take the end substring. So what I will do is I will figure out all the substrings. Now to figure out all the substrings, what you do is, if you are at a I, so you will try on for all the J's which are forward. You are at I, you will try for all the J's. So which means if I am at this I, I'll try for this J, this J, this J, this J, this J, and so on and so forth. And same if I am at this specific I, then I'll try for this J, this J, this J, so as to make a IJ pair. That IJ pair is indicating that this is my specific substring. Now I'll try for all the possible substrings, and I will then check if that substring is a palindrome or not. And to check that, I already showed you that we will just compare start and end, start and end. If it is odd, then you can skip the middle one, but you will just compare the start and end. Now to make all these substring, it will take n square time because it is n square substrings, and to check for that specific one substring out of the n square substrings, I'll take again a O of n time to just check. Okay, I'll compare start and end, and that's how I will take O of n time to just check if that specific substring is a palindrome or not, and thus you will be getting a time complexity of O of n cube, which is okay, but still it's high. But let's quickly have a glance at the brute force code. Although in an interview you will just speak up with this code, you will not be coding a brute force code ever in an interview, because interview is a very short span of time in which you have to get to the most optimal approach and have to code the most optimal approach. So just brute force says if the length is 1, simply return the string itself, because it's just a one string, one character is always a palindrome. If I have a it's a palindrome. It's just simple a base case. Now it just says that I will initialize my maximum length, because you know that length at least will be one character palindrome, it will be at least one. Now I just went on and tried for all the substrings. It is for trying for all the substrings, and when I try for all the substrings, I will just check, okay, if that is a palindrome, then this is palindrome function we have made differently, which will just go and check, just comparing, okay, start and end. It will just compare left and right. Now while left is less than right, which means I'll just compare my left and right. If it is not equal, then simply it is not a palindrome. Else I'll just simply keep on reducing, which means left will keep on coming inside, right will it will will keep on coming inside. So basically left and right are at the extremes, it will keep on coming inside and keep on checking the pointers so as to check if it is a palindrome or not. If it is a palindrome and also I want to maximize my length, so if I am getting a new length, a more length palindrome, then I will update my answer with the maximum length and update the maximum string, which is the longest length palindrome. And that's how in O of n cube we can solve in brute force. But now can we optimize it? Yeah, we can. How? It is just simple that while you are seeing that, okay, you already know that this CEC is a palindrome, right? And then while you were computing for the new substring, which was ACECA, then you were again checking the entire thing, right? Now I say, bro, if you know the middle part, if it's a palindrome, then why can't you reuse that middle part in the bigger part? Right? So I can just reuse something. Now when reusing your pre-computed values comes in, then for sure first thing comes in our mind is the memoization, which is actually the father of reusing stuff. Memoization is built just so that if you are just trying to compute that same thing again, then you will just reuse that. So I'll just use the same thing, that okay, I know that this portion is a palindrome, so I can mark, okay, true or false from I to j. If it's a palindrome, okay, I mark this as a true, so that in future when I am computing, let's say from this I to this j, so for sure it will go inside, which means it will go and do a I plus plus, it will go and do a j minus 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 minus. So now it will land onto a new I and j, but I will have pre-computed this value, so I will just simply return that okay, it's a palindrome. And that's how I can use memoization to solve this up. That's so wonderful, right? So I have this LNR, simple, you know, memoization, okay, which means I will have to write a recursive code in which I have two pointers LNR and they will be moving inside if I actually encounter them as the same value. So okay, I have to write the recursive code as in I have to write a base condition. Base condition will look something like, okay, I have two pointers LNR, right? Now base condition is very small condition. What if I will have just one character? That's a simple base condition, right? What if I have two characters? That's also a base condition. So as simple as that. If your L is less than equal to R, now in this again two conditions will be there. L is equal to R, L is more than R. Now when L is more than R, which means your pointers were earlier at L and R, then it's surpassed. Now okay, if it's surpassed, which means okay, you have valid, okay, because you are only moving and saying it's valid. And then if you had surpassed this, okay, which means everything you were saying was actually valid and then you surpassed from here. So I will say you are moving, okay, you are at this location, same, okay, it's valid. If it has surpassed also, it is valid. Again, in this you can also modify this check as L and R. If it is less and you just have a difference of 1, which means L and R are just like this, adjacent to each other, L is here, R is here, then also if they are same, you can also return a 1. Or this condition we can handle in our recursive code, and then when it will actually go inside, then L will surpass R and then I can also return a 1. Okay, that's a simple base condition. Recursive condition, you also know, I also know that simply L and R will be the states of my DP, and DP is just but okay, recursion states, and then I can memorize the same states to make a DP state. So I'll just simply get and return a L comma R. Now comes the actual recursive cases. Now simple, as we saw, okay, if both are same, then I can move inside. Okay, if both are same, then I can move inside. So if both are same, which means S of L, which means this specific string character, if both are same, then I can go and move inside. So if this is same, then you can try for the smaller subproblem, which means L plus 1 R minus 1, L plus 1 R minus 1. But if it is not same, bro, L and R will never form a substring. Please return a false from here itself. You cannot even go inside. That's the reason. If they are adjacent, then it will be same. So it will get onto this condition. Then L and R will increase. So L will go here. R will actually come here. So it will become something like this, and something like this. It will simply return a 1 because it's valid. Because in this here condition, we have make sure that if it is not valid, I am simply returning a false from here itself. Now it is a simple case which you saw, base case, memoization and recursive code, which you have to replicate in the code. L is more than equal to R, simply return a 1. If your DP value is not equal to -1, simply return the DP value. The simple two conditions which we saw, that if your value. If it is equal, then simply return that value, which means increasing L and decreasing R. And for sure, in ultimately, if it is not, which means if it is not equal, then simply return the false itself from here itself. And for sure, the simple conditions, we in the main function, we just initialized our n, then we initialize the maximum length and starting index just to say, okay, I'm starting from this index itself. And why by starting index? Because ultimately, remember, in the answer you want the string, not the length, right? So starting index will say, okay, I'm starting from this index. My DP will say, okay, this is the length. Starting from this index, length is this, I will get the string. So I'll simply memset my DP by -1. You just can have it. Then I go on to all the substrings and I'll just call my solve function. But bhaiya, for all the substrings you will call the solve function of n square times, which means this, because we saw that this is a n square time operation, then for all the substrings you're calling it is n⁴. This is way too much. No bro, it actually in cumulative will be O of n square. Why? Because for a state which was already computed, as soon as you will try to compute the solve function, my DP will itself return the value itself. So this entire thing will be O of n square itself only. And now I'll simply go and check if the maximum length which I have got because of this solving my I to j, if that is more, the length which I have got, if that is more than my maximum length, then I can update my maximum length. I'll update my maximum length, and then I can also update my starting index, because starting from this index for this as the maximum length, I'm getting my answer. Now, when this entire portion is done, which means when you have tried for all the substrings, you can simply return your substring starting from this index of this maximum length, and that will be your answer. Simply the time and space will be O of n square, because of you saw that the DP states are L and R. L and R are both I and J's. I and J will be simply going to n and n, and also space will be same as that of the time, because you are using a DP which is L and R. Now the same thing, if you want to write, if you are much curious about bottom up, the same thing, exact same thing, you'll see exact same thing I'm saying, because in this you will see you are going on to all the substrings, and then you are just going and checking that, okay, if the answer is valid, simply increase the L and decrease the R. Exact same thing, we can replicate that in our method 3, which is the bottom up approach. I'll do exact same thing. You will see the code is exactly same. It's just that I'll go on to all of my substrings only when the characters are equal, and also this is the base condition to handle this base condition. And here I'm checking the same stuff, that j plus 1 I minus 1, if it is actually true, then okay, my substring portion is actually a proper palindromic substring, and then I can simply go inside and update my maximum length with this current new length. So I'll update my maximum length, I'll update my starting index, and that's how I can simply get things done. I'll have my starting index, I will have my length itself here, and that's how I can simply return the same approach. It's the same top-down approach, bottom approach are more or less same. It's just that how to write that stuff in the bottom approach, and the same time and space complexity, nothing much. Now comes the interesting part. Can we again optimize this? Interviewer will ask you. So you will see that, okay, you use the concept, this was the window. Now you could have expanded that and made this. Now you remember, okay, I was using, I can memorize this window, right? Now what I'm saying is, if you just stop here and think, okay, this was a window at the first place, right? And you want to memorize this window. Okay, what's the answer for this window? Now remember this, it's a window, right? Rather than expand this window, that would be great, right? So what I'll do is I'll simply expand this window. And if I can expand this window, I'll know, okay, for this L comma R, if this was a palindrome, I can just simply try to expand this window itself so as to get a new palindrome. So basically what I can say is, I am starting with this E, I'll try to expand this, okay, check my C and Z, it is same, okay, again, try to expand this A and A, great, then try to expand it, okay, R and R, and that's how I can simply just try expanding, and then expanding itself I can just store. Okay, what's the answer? Now the same way, now this you'll say, bhaiya, this was for odd numbers. Okay, the same way will actually go for even numbers, that okay, you will have L and R. Here, although you remembered L and R were at the same location, where it was the odd length thing. Here L and R will be at the different location, as in okay, L and then adjacent to that is R. And then you can just try expanding the same way if you are encountering the same character. So one thing we got to know that okay, for odd length I will have to try expanding, saying L and R both at the same index, and then for the even length L and R at the adjacent index. So I will have to try for both of them. But bhaiya, how will we know that when to try for odd length, when to try for even length? Bhaiya, but I'll say, because you know the string length. No bhaiya, because we want to find the substring. Basically, if I'm at this index, if this is my I, so what, how about, like, how I would know that will it form a odd length substring or will it form a even length substring? How would I know if I'm at this I index, right? I will have to go on to all the places and then figure out, yeah bro, you are right. So what you can do is you can try for both the things, which means at this location you will try for expanding at this as considering this as the odd index, which means you will try and place both your I and J or L and R at the same location, and also for this exact same case you will try for placing your I and J at this adjacent location, so that at the same index I am trying to imagine it as both. I'll try to expand it as an odd index palindrome and also an even index palindrome, right? So I'll do the same thing. I'll do that for both of them. For this specific index I'll try to expand this considering okay, it's an odd, and I'll also try to expand this considering it is a even. I'll do it for every index. I'll try for every index. I'll try for both the ways, both the possibilities, and that's what simply we can do. Now in this again you will see here again it will try for all the I's, which means for this I, I'm just simply expanding. So for all the indexes I'm trying for expanding it up till the end. So for all the indexes I'm trying to expand that. So simply is for all the indexes n operation, I have n indexes, still bhaiya it's a O of n square time. Then what is the benefit of it? Benefit is in the space. Benefit is in the space. Now you would not have to store the space, so you will see the space complexity is actually O of 1, because now you don't have to store it because you are expanding from here itself. So you already know okay, shorter answer I have computed, and then I'm going on to bigger answer. If it is not even possible to go on expand, then okay, no worries, go on to next. Don't store, never store it, because you are always expanding the palindrome itself. Now in this exact same stuff, roughly same, n, if n is less than or equal to 1, return the string. Now this is actually a function inside this function, so I'll show you that what it does. But let's go on to your maximum string, which will be your answer. Firstly, I got the starting character itself in my maximum string. Now I'll go on and try for all the indexes. Now for all the indexes I will go and try to expand them. Now okay, I just meant I'll just get the odd length string and the even length string. Now to get the odd length string I'll say okay, it's, as you remembered, for the odd length string my L and R are just the index I. For the even length string, which I am imagining to be a palindrome, it will be a I and I plus 1. So again for the same stuff I'll try for the odd length string, I'll try to expand it from the L and R as I and I, and for the even length I and I plus 1. Now what the expand function is doing, it simply is trying to expand that from L and R. So I have that left, I have that right, I just simply try expanding, which means okay, if left and right are same characters, then try for left minus 1 and right plus 1. So if the left is more than or equal to 0, right is less than n, and if they are same characters, then try for left minus 1 and right plus 1, left minus 1 and right plus 1. Try to expand that, and ultimately I will have my most expanded by this loop, considering they are both valid, and also I have not reached the end of my string, any portion, left end or right end. Then I can simply return my substring starting from this with the length of this. Because I have my left, I have my right, I know that I'm expanding. It is a valid, later on it will check if it's a valid or not. So I know one thing, okay, I know that okay, I'm expanding. So I'll just simply know one thing, I'm expanding. So I can simply go and check, okay, left plus 1 with the length of this length, which is right minus left minus 1. Then ultimately I'll just simply go and check, okay, what's the length or what's the string which it returned, and ultimately if my odd length is more than my maximum length, then update my maximum string as odd string. If the even length is more than my maximum length, then update my even string. And that's how I can update, okay, whatsoever string, either odd or even, is for the index of 5, just update that with the maximum string and ultimately return that maximum string itself. Thus you are only using your O of n time and no extra space is being used, because you are expanding from every index you are expanding from. And that's how you can simply solve this. Last is the Manachers algorithm. Now again, you saw there were 4 follow-ups for the existing problem itself. So it is not even expected to solve this in an interview, and it is not even for the interview itself. This is like legit entirely a very big, around 30 minutes will be taken to explain this algorithm itself. The only benefit of this algorithm is that you can solve this in O of n time and O of 1 space. Although for this, as it is not interview specific, it is way out of the approach or basically the bound of the interviews. So if you still want, you can just watch Algorithms Made Easy, this video. They have a great animation for this corresponding video and you will get the values. Like, understand that if you want to understand, although it's not quite at all. Cool. Thanks for watching. Bye bye. And thank you so much. We will be continuing this series in which make sure you have to make sure do these questions for placements, because these are the questions which are most frequently asked by companies, and this is not BS. It's actually in front of our eyes. In last 6 months, it's very frequent. So for sure, it will be asked. Bye bye.